Okay, let's look at example 11. A spherical balloon is being blown up such that after t seconds, the radius has grown to 2t. Okay, so again, a test of your information gathering and also your interpretation. Okay, so the very first thing we need to look at is it is spherical. Okay, now the second thing we need to look at is this radius has grown to 2t cm. That means to say what? Your r at some point of time equals to 2t cm. Okay, and what is your t? T is actually time. Okay, so these are the information that you gather. Now let's look at the question at issue. The question at issue is, what is the rate of change of its volume? Meaning to say, what is v dv over dt representation? Okay, now that means to say another interpretation. That means you need to find v connecting t. Now in the very first place, okay, it is spherical. That means to say your v is actually 4 over 3 pi r cubed. Okay, there is no connection between v and t. It is v connecting to r. But because, okay, there is a condition that r equals to 2t, okay, we can actually replace, okay, the r by v equals to 4 over 3 pi 2t cubed. Then guess what? This will become 32 over 3 pi t cubed. Now this is your v. Okay, are we done? Almost. Okay, right now what you have is you have v connecting to t, in which this is what we want. Okay, because we're going to get the dv dt. So the next step we're going to do is differentiate dv over dt. That will give you the rate of change of the volume. Now that gives you what? That gives you 32 over 3 pi t cubed. Bring down the 3, becomes a square. And of course, with that, the 3 and the 3 is eliminated, and you're left with 32 pi t squared. Okay, so therefore let's answer the question. This is problem sum. Rate of change of volume is given by 32 pi t square units cm cube per second. Okay, so this is the first part. Now part 2. Okay, how fast is the volume increasing when the radius is 8 cm? So meaning to say at r equals to 8 cm. Okay, or rather, since you're talking about value at r equals to 8, okay, what is my time? My 2t is equals to 8. That means my time is actually at 4. Okay, so how fast is the volume increasing? We know that the rate of change is 32 pi t square. So the rate of volume increasing simply means 32 pi and then t square, 4 square. That will bring you to 512 pi cm cube per second. Okay, now part 3. What is the rate of change of the surface area? Okay, I'm going to go a little bit faster because it's a repetitive thing from your part 1. So what you need to do is surface area for a sphere is 4 pi r square. Again, when r equals to 2t, your area in terms of time gives you 4 pi 2t squared. Now that gives you 16 pi t squared. So your dA over dt, that will give you the rate of change of the surface area. 16 pi, bring down to t power 1. So you get 32 pi t. Okay, so rate of change, answer the question again with a statement of surface area is equals to 32 pi t. This is cm squared, not cm cubed per second. Okay, and last part, when radius at 8 cm, again repetitive. Okay, if you can, pause and then finish it out on your own. Then just drag the video to the end to check. So when r equals to 8, okay, my t is equals to 4. Same thing that what you've done before. I'm not going to elaborate more. So the rate of surface area changing, okay, this will be equals to 32 pi, and then the time is 4. Just plug in the 4, and then you have 128 pi cm square per second. Okay, rather long example, but you notice that the repetitive pattern. Okay, so if you can, just skip a few of the steps.